folder, and the switch itself we'll be looking at next. So the next thing to do with the switch is to get the value from the environment channel group, which tells us whether the light is on or off. We want that value to be accessible from here so that we can use it to change the rotation of our light switch. So if we go back to the dual view, what we can do is get the environment group in here and tutorial 4 there. And we just got to find that value now, and the value here is the toggle flip-flop value which we created earlier. So I've just gone and made a link there, and you can see it's appeared as a public channel, so that's okay. So let's go back to the single view and see if that works. The first thing I'm going to do is connect it straight up like that and see what happens now when we turn the light on and off. So when we press the L key now, you can see, as well as the light changing, the switch itself is changing as well. So this is exactly what we wanted. What I'm now going to do is show a new channel called the inertia or value damping channel. Now what that can do is just basically give it can give a delay to the transition of any particular value. So if we use that here, we can make our light switch move a bit more slowly. So if I go to the inertia in the channel list there and drag it in, you can see we have our inertia channel, and if we connect that in between, what we can do now is when we turn the light on and off, can you see there's a slight delay between the movement of the switch? It's no longer instantaneous. It looks like it's actually moving from one position to another instead of instantly appearing on or off. If we reduce this value, we can increase the time it takes to move from one position to another. So you can see now it's much slower. So that's a really useful channel. You can use it in all sorts of situations. Let's now look at creating an automatic door for our scene. We'll first focus on importing and positioning the door. So I'm importing the X file, and you can see, as always, it's imported into a new group. So let's copy it from this group and paste it into our tutorial 04 group. So now we can delete the old group it was imported to. Let's now connect it up to the renderer. So our main renderer is here in the start group, and we're going to connect it up like that. So you can see our door is now connected. So now if we go to the animation section, we should be able to find our door on the list. Here it is, and now we've got to position it correctly. So what I'm doing is I'm dragging it over, and you can see here it is. And can you see also that the gizmo here is located exactly where we want the pivot point of our door to be. So if I go to rotate, you can see it is rotating around the correct position. Now that's been set up in 3ds Max. Basically, when you export from 3ds Max, the pivot point of your objects will be 0, 0 coordinates. So in this situation, what we've done is export with this point here being at 0, 0 coordinates in 3ds Max, and that means when it's imported into Quest, the pivot point will be exactly there. So this is already set up. What we've got to do now is just position the door where we want it to be. So I'm just going to do this by eye. Okay, so that's approximately right. Let's leave it there. Let's now look at how we can get the distance between two objects. Now what we want to do is set up some logic so that this door can be opened and closed automatically depending on whether you are near the door or not. So when you come close to the door, it should automatically open, and as you move away from it, it should shut again. So if we go over to our tutorial 04 group and find the door in here and unpack its motion, let's find the value first of all that we want to be dealing with. So we've got our rotation here, and if we just change our little view down here so that we can see the door in sight, we can then double click the value that we want to be working with, which is this one here, and then isolate that and start to build logic around it. Now the first thing we want to be doing is working out whether we are close to our door or not, and the easiest way to do that is to use an operator. What we're going to do is use a value operator, and I can get that from the channel list here. Now, a value operator is basically an operator which results in a value. So what we want here, we want to end up with a value, and that value should be the distance between the camera and the door. So that's why we've chosen a value operator. You can see there's also vector operators and matrix operators. So a vector operator would be an operator where you want the result to be a vector, and the same thing for a matrix. So we've got our value operator here. What we've got to do now is double click it and choose from all of the possible operators here the one which we want. Now the one which we want is get distance between two vectors. So you can see here get distance, and then in brackets it's telling you the children that this particular operator requires. So it needs two vectors, so that's perfect. So we've got that now. Now the next thing we do is we need to get shortcuts from the two vectors. Now one of the vectors should be the current position of the camera, and the other vector should be the position of our door. Now the door is easy. Here's the motion of our door, so here's its position vector. So let's take a shortcut from that. And now what we need is to get the position vector from our camera. So I'm going to go back to the dual channel view, and we're in our start group here. Now we need to find the position of our camera. Now you can see here there's a vector here called out movement position. Now that's the current position of our camera. You can see as we move around using our camera view, you can see this change. Now this is exactly where we are in world space. So this is the vector we want to be dealing with. So let's just link that up down to here at the moment, and you can see it's created a public channel in our tutorial 4 group just as we want. So now we can go back to the single view and connect both of these up, and hopefully this operator will now give us the distance between these two vectors. So to start with, let's just connect this straight up to our rotation vector here and see what happens. Now you can see it is doing something already. Can you see as we move with our camera, the door is actually rotating. So as this value changes, the distance between them, the door is opening and closing. We're now going to look at using a new channel called the expression value. So now we want this door to only open when we get within a certain distance of it, and then to close again when we get outside of that distance. So the first thing we need is another channel. So this channel we need is called the expression value. So let's drag that into the channel graph and have a look at it. So if we double click it, you can see we have a space here where you write expressions. Now basically this channel allows you to perform mathematical operations using values. So you connect values as children, and then you refer to these values using letters. So you see the first child will be referred to as A, the second child as B, the third child as C, etc, etc. At the moment you can see it's telling us that we don't have any children linked. So if we just get a couple of values and link them up, say 1 and 2, let's put 5 in the first value and 2 in the second value. Let's now connect that up to our vector here. Now you can see it's telling us we've got our two values connected, A and B. We would refer to them in the expression. So if we put A plus B, you can see it's now giving us the result of that expression. So A plus B, 5 plus 2 is 7. So that's what we're going to use now, but we're going to use it in a slightly different way. What we want to do now is just basically for it to give a value of 1 when we are within 5 units of our door, and 0 when we're not. So in here I can just put is A greater than 5. Now that's basically just going to give us a value of 1 if it is greater than 5 and 0 if it's not. So I've connected it up as the first child, so that's A, and let's have a look and see if it works. So you can see, can you see now as soon as